Theory of Constraints Explained: How to Remove Your Greatest Bottleneck. In this video, I'm going to summarize the theory of constraints into a couple of really key concepts and help us to be able to manage construction projects because we have this on our mind. Please stay with me on this video. Okay, so let's talk about this right now. This is a beautiful concept. I love Eliyahu Goldratt. I love the book, The Goal. I love the theory of constraints. I love critical chain project management, and I love the rules of flow. It's absolutely phenomenal. And one of the things that I was super impressed with is going to Japan with Paul Akers was great, but he's known for small 2-second lean improvements. But Paul knows all about these big time concepts, and he knows about the theory of constraints as well. Theory of constraints, what is it? It's basically a theory that in your system, you will experience what's called the law of bottlenecks, which means that every system will have at least one single most limiting factor, and that you will be constrained by that bottleneck or that limiting factor, and that once you optimize and remove that one bottleneck or constraint, then another one will show up in the system. And it's absolutely wonderful because you can look at product or process flow and literally find out where your bottlenecks are. It's really phenomenal. And so you go there first, and one of the main theories is don't sub-optimize areas that aren't your constraint. Go to your constraint first and subordinate everything to that constraint so that we can have the ideal amount of process or progress flow or piece flow throughout the system because you've identified and optimized and subordinated the system to and improved your bottlenecks. I can give you a really neat analogy. I've done this before. Let's say you have a factory and you have inputs and outputs, and the amount of product that goes through the factory in a certain period of time is called your throughput. Well, let's say you have one piece of equipment that does 4 parts per hour, 4 parts per hour, 4 parts per hour, 2 parts per hour, 4, 4, 4, 4. I asked the question, what is the throughput per hour for that factory? And people are like, well, 4, 4, 4, 2, 4, 4, 4. It's 2. I let that slide for a minute. I'm like, okay, what can we do? And they're like, okay, well, the bottleneck is the 2 parts per hour machine. Well, let's just get another machine or replace it for a 4 part per hour machine. Great. Now what's the throughput of the factory? Well, you got 4, 4, I got 2, 2, so that's 4, 4, 4, 4, 4. Okay, the throughput of the factory per hour is 4 parts per hour. Okay, great. That's super good. I love that. And that's irrespective of the takt time. This factory can basically produce 4 parts per hour. Super fun. I am like, okay, let's say you can't speed up that 2 parts per hour machine. You can't get a second piece of equipment. Let's say that's the last piece of equipment they ever ordered and the whole line would have to be replaced. There's nothing you can do. What else could you do? And sometimes people get around to saying, well, you could slow everything down to half production, half production, half production, to half production, half, 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 half. I was like, okay, if you slowed everything down, what's your throughput? 2 parts per hour. And then the great reveal comes. And I'm like, okay, the first option, if everybody's working at full capacity, is actually not 2 parts per hour. It's like 1.8 to 1.2. Because after the last 4 part per hour machine and ahead of the 2 part per hour machine, you're overproducing inventory and it's being staged everywhere, and labor is having to swarm because you have overproduction, which leads to excess inventory, which leads to transportation, which causes motion, which creates defects, which have to be fixed, which is overprocessing, which creates waiting. And it's all a waste because you could have used the genius of the team. So those are the 8 wastes. And 7 if you get rid of the genius of the team item. Now you have labor throughout the factory trying to manage the excess inventory, so now you don't actually have 2, you're down to 1.8 to 1.2. So the first option was the least productive. So if you speed up that bottleneck from 2 to 4, now you have 4 parts per hour, that's fine. Or if you slow everybody down, you have 2 parts per hour, that's fine. So the fastest option is to get a new machine at the bottleneck. The second fastest is to slow everything down to the pace of the bottleneck. And the worst option is to have everybody go as fast as they can, even though you have a bottleneck. And so the theory of constraints is focus on that literal bottleneck and pace everything to it. And if you can optimize it, then another bottleneck will show up somewhere else in the system. That's probably the best way for me to communicate it verbally, visually. But the bottom line is the theory of constraints says that you will have a limiting factor, and once you improve that, that's called the law of bottlenecks, you will have a second one show up, and it's in the system. But lean practitioners took Eliyahu Goldratt's The Theory of Constraints in high mix, low volume, and in line manufacturing, or in manufacturing in general, and just took the term constraint. constraints. But that's actually not accurate for construction because we have a system, which is the train of trades and the train tracks, which are the zones. And then we have things that can be in the way of our production flow. Our flow unit is the train of trades, so we can have a constraint in the train of trades and in the zones, which are the train tracks. But we can also have things in the way, like plywood, weather, space not ready, whatever, missing information. That's called a roadblock. And the reason the theory of constraints is important in construction is because we now know that instead of going out in the field and fighting fires, we need to be looking in a phase for the slowest trade, the hardest zone, or the most limiting factor that's slowing down production, which could be information or logistics or whatever. And we solve the problem there first, if possible. This helps to shape our view and to focus on the right things. And if we don't understand that train of trades concepts and the train tracks with zone concept and the most limiting factor concept, and if we don't separate constraints and roadblocks out, we're not going to be able to see what we need to see. So theory of constraints is, in construction, we identify our most limiting factor in a phase, which will typically be the slowest trade, the hardest zone, or your most limiting factor that's slowing down the production flow of your train of trades through zones. I'm going to turn this into a blog post for you, but reach out if you ever need help. Also, there's a video called Tax Steering and Control that shows this beautifully, and I will share that in the description below. I hope you've enjoyed this video. On we go.